Now today let's see how garbage collection works in Java and how we can know what objects are being removed and what we can do before an object, or how we can know when exactly an object is being removed. Now we know when objects are created on the fly, that is an object that has no reference, and that is an object which is ready to be garbage collected. Now what we'll do is we'll create a number of such objects that really shake up the memory, so that the memory gets so short that the garbage collector needs to run and it needs to remove such objects from the memory. So let's just get started and see how we can work on this. So let me create a class whose objects will be creating, say, gc demo. Let's create some variables for this so that it has some weight for every object. Let me name this as student, and let us take some variables, say name, father name, section, and we can have roll number and say marks. So we create a class called student, has some variables as part of it, and now let's have a method here, say static void create objects, and this will create a number of objects that will really stoop the memory to a level where there's no more memory left to create objects, and the system will need to run the garbage collector to remove a number of objects. So what we'll do is put in a loop here, int I equal to 0, say we're looking for 10,000 objects, and we'll say new student. Now in order to have a count of what exactly is the number of students that we currently have, let's have a constructor here with a counter, say created, and what we do here is that we'll simply call this method create objects. So let's just go through what we've done. We're trying to see how garbage collection actually works in Java. We need to know when objects are removed, and let's see when exactly does the garbage collector run. So we need to see all those things. So we started with the basic structure of a class whose objects will be trying to create objects which are all without any reference. So these are all ready for garbage collection, and we simply run a loop that will be creating these objects. So let's run this and see. As of now, we haven't written any code that deals with how objects are removed and how do we know when they are removed. So in order to know when objects are removed, there's a method called finalize, and you need to override this method in the class where we need to see what exactly happens when an object is removed. So this is a method which is definitely called before any object of class student is removed. So we'll put down a print here so that we can know when object is removed, and let's put some counter to this, say destroyed, and so there's a code to track what is the count for the object which are created, and there's a track of what number of objects are removed. So let's run this and see what exactly happens here. So a number of objects created, but they're all 0. So let's see why they are all 0. And nothing removed. So it's been able to create 10,000 objects without any memory loss, so that it needs to run the garbage collector. As I've increased the count from 10,000 to 1 lakh, but the main thing is, why is this 0? Why object created with a 0? Now this is because the created is an instance variable, so it again starts with 0 for every new object, and also we haven't incremented this. So let's again try what happens now. Object created. and the garbage collector never runs. So since this is an instance variable, it again starts with 0 for every object. It goes to 1, but since every time you create a new object, it again starts with 0. So let's make this static and make this static too. Well, let's run this and see what change it brings. So as you can see, it's created 99,000 objects without running the garbage collector. So it has enough memory so that the garbage collector is not required at any point of time. So it's not that when the number of objects are there, it needs to run the garbage collector. It doesn't need to run the garbage collector till the time it finds the need to run it. So instead of 1 lakh, let's make this 10 lakh so that the number is exorbitantly high so that the garbage collector actually runs in this. Let's see how this goes off now. Oh, so now it comes. Now we got a number of objects with I think I made a mess of this here. Oh, I haven't incremented this, so let's do this and again run this. So now if you can see, it's removed 37,000 objects, and it might have created more than a lakh of objects. We can't go beyond a certain limit. So it might have generated an object in excess of 1 lakh, and then subsequently the memory it felt is low enough for further objects to be created, and this is what prompted the garbage collector to run. And before any object of any class is removed, the system calls a finalize for that object. So whatever you need to free from that object, you can write the code within this finalize, and then the object will be reclaimed by the garbage collector. So before any object is removed, you get a final chance to free any resources that the object holds in the finalize method. And since we don't have anything to free from the object, we simply have a print that shows what is the number of object that is currently being destroyed. So hope this clears how garbage collection works. If you have a number of objects that are all without reference, they all are ready for garbage collection, and a stage comes when the memory goes below a level where further object creation is not possible. So the system calls up the garbage collector, and it then frees up the objects from the memory, and before removing any object, it calls the finalize method on that object. So you need to override the finalize within the class whose objects you are expecting to be removed, and then we can track what objects are currently being removed. So this is how you can work with garbage collection. Hope this clears and you find this interesting too.